You ready?
Good.
Good to go. Fantastic. Yeah, good afternoon, everyone. I guess we'll start with quick introductions. First, I just want to thank folks that are here. I know you all have lots of things to do today, like labs. Yeah, I appreciate the time. My name is Cody Brown. I'm the channel, regional channel account manager, if you will, for Stratus, sales manager. I've been in the industry for probably 8 years or so for Rockwell for most of the time, and then doing some other networking focus type things, and now with Stratus for the last 9 months. I'll let Cole Cranford introduce himself.
Good afternoon, everyone. Cole Cranford. I'm a customer success engineer with Stratus. Relatively new to Stratus, joined last year, 2018. My background is in computer science and software development. Most of my career to this point was in the offshore oil and gas industry here in Houston, mostly with subsea control systems.
So yeah, he's an oil and gas expert on the Stratus between the two of us.
I'm relatively new to Stratus, but I've actually been a Stratus end user since back in 2005 or so time frame. So I use those in various oil and gas positions to run our subsea control systems on facilities out there in the Gulf.
So pretty relaxed today. If you have questions online or in person, just pause me and ask away. But you know, for us, there's this big transition we're seeing with the whole digital transformation, connected enterprise, IIoT, in which the edge computing is going to become the forefront, where most of the decisions are going to happen, contextualizing data at the edge. And today we're going to talk about how Stratus provides solutions into that space. But first, I'll just start with, you know, who is Stratus? We've been around for about 40 years. We have 12,000 plus systems installed throughout the world, and customers under support today. And we provide the world's most kind of reliable computer. And for the last 20 plus years, we've provided one product called the ftServer, stands for fault tolerant server. We'll talk a lot about that today. And really the transition for us has been more to the edge automation space. Where we really started was in the financial institutions. So really expensive downtime, expensive transactions, et cetera. So think of Amex, Bank of America, credit card transactions, as well as stock market industries, et cetera. But as the pricing of the solutions and the criticality of data in manufacturing has become more and more paramount, and the hardware less and less costly, we've seen this rapid adoption really the last 10 years or so in the industrial automation space for our solution, providing availability in a simple manner. So what we're trying to do across our portfolio of products, which are really it's not too vast, it's a couple products, is we're trying to simplify edge computing for this whole digital transformation or the connected enterprise. And we do that really in 3 ways. The first one being simplifying edge computing. The solution can be set up really quickly. It's easy to manage and maintain, and easy to get back up in either duplex mode or redundant mode. The other thing that we provide is a hardened solution. So from a ruggedized platform like you're looking at today with the ZTC Edge that we have up here, to from a security perspective, making sure the data is secure. Also providing a seamless failover without a ton of interaction from the user to keep a system that normally takes an IT type resource to keep it up and running in a redundant mode and redundant manner. We've tried to simplify that so anybody in this building can support our solution. And then lastly, the autonomous piece. We want our solutions to monitor themselves, tell customers, clients, et cetera, if there's an issue forthcoming or there's an issue immediately. Because we like to say, Cole and I do, that Stratus allows you to get out of jail free, kind of one time, get out of jail free card once, meaning it's in a duplex mode. You can withstand a failure, keep running, but you got to get your solution back up in duplex mode as quick as possible. So being able to be alerted and alarmed and notified that there's an issue is really important. And then that automated replacement is really key for us. That drives back to the simple piece. And we'll talk about all of these in some context today. So what, in the industrial automation space, I mentioned in the last 10 years, we've seen this huge wave of significant growth. Here's just a couple, few lists of customers from discrete all the way to kind of continuous process customers. So many names that we'll all recognize, everything from oil and gas to food and beverage and water, wastewater, everything in between. We probably have a success story and a customer in any industry customers in here or on the phone would be involved with. So like for me, and I think Cole, and one of the reasons that I'm really excited about the trajectory Stratus is on is because edge computing, this digital transformation, IoT, all these buzzwords that we hear, connected enterprise, is real. And with all these smart devices, more and more data is coming. We probably all heard that the last 3 years more than we want to hear it. But it's true. This shows you kind of the trajectory of the data and 40 zettabytes and IoT data in 2019, 80 in 2025. It's rapidly growing. What we think is, the use of cloud will be important, but contextualizing data using analytics will be needed to happen as close to the application as possible. We think that, whether it be a facility that's remote, a line, a rig, et cetera, all of those assets create tons and tons of data, but contextualizing and processing the data at the edge, at the application, is where we see the industry really heading in a really quick way. And so thus, providing servers that are easy to use, easy to support is a great opportunity for us to provide more benefits to clients with the massive amount of data coming.
And I would say in my time in oil and gas, the last 15 years or so, I certainly saw this to be the case, right? So, as time went on, we would see more and more instruments in the remote sites and in the production facilities. And each of those instruments would in turn be providing more and more data. So, through my time, we were seeing almost this exponential growth in the amount of data that was available, at your production facility or at the edge. And, especially with remote sites, it was prohibitive, for a number of reasons, bandwidth, cost. It was difficult to collect that data at the edge, ship it back to a data center, process it, and then return that back to the facility to enhance operations, right? So that's why, certainly in oil and gas, and I feel the same with most industries, gathering that data and using it at the remote site with that edge computing element is going to be key.
And I think, yeah, absolutely. We talk about this almost weekly right now with clients is the amount of data that they have and how to contextualize it, but also who supports it at the end of the day. Whenever there's a remote plant, remote site, equipping, say OT folks, right? Automation engineers, et cetera, that don't have an IT background to keep the servers running is probably the second thing we talk about a lot. Yeah, very wonderful. These numbers are a few years out of date, but I doubt they've gone dramatically up or down. The idea of why folks buy Rockwell Automation, why they run FactoryTalk USE, Historian, et cetera, is because they have to operate facilities, and applications running allow plants to continue running. And there's a couple statistics here that say the cost of downtime, how important it is, production loss when there is an issue with your application in different industries. The slide really is just saying more than ever, applications running on servers, information, security, et cetera, are all vastly important, and they're only getting exponentially more important because we have less people working in the facilities, right, to support the infrastructure, get it back up and running, and downtime and uptime, just that they're absolutely critical. And so for us at Stratus, that's really what we provide. So we like to talk about unplanned downtime, and I'm going to go through this chart. It's kind of lengthy, but it talks about availability percentages on the left side. If you notice all the different nines, and what it really comes down to is if you think of a Dell or HP tower computer, so picture like a computer that used to go under your desk, or like a blade server. We call that a non-redundant computer. So if you notice there, it's 99.5% available, and thus it has about a day to 2 days worth of unplanned downtime a year. The next best solution a lot of people are talking about these days, more and more, is kind of cloud availability. We had a customer a couple weeks ago that lost power wherever their private cloud was, and they couldn't connect to their remote sites, and thus they lost hours and hours of data and information. And so it's a good example of this, right? The cloud is great, and you can put some redundancy in place so you don't lose connectivity. But I think AWS or Azure will put on their website that they are 99.95% available. So less downtime, less unplanned downtime, but still 4 to 5 hours of unplanned downtime. Another popular solution that we see is a clustered redundancy. So taking 3 servers, 2 or 3 servers, having using a VMware or whatever hypervisor to fail over. They call it HA, highly available solution. As that application would fail over, you're going to have downtime as it restarts. So there's an hour roughly of downtime there, they say. The other challenge with that solution is each server that you have to have a software license associated with it. So we're actually working on a project, a Rockwell project right now that had this conversation yesterday, where they're looking at a clustered solution and having 3 licensing or 2 licenses per server, depending on however many servers they have. And the challenge with that solution too is the ability to support it. Usually it takes an IT resource to stand that thing up, get it running properly, and ensure it continues to run properly. So Stratus, we're down here at the bottom, the 7 nines, it's 3.15 seconds of downtime per year. It's what the 12,000 clients that we talked about that are under support today have relied on Stratus to provide for the last 40 years. So we'll talk about both our solutions and how we achieve this here shortly. But before we get there, kind of to talk about the traditional, modern, and kind of modern edge architectures, there's really the 3 buckets we have here. On the left is just a traditional single application running on a single computer. It's really popular out there today. By contrast, a lot of folks in the industry are talking about virtualizing and the ability to support virtualization. I know Rockwell has virtual image templates that have been created for their software suite that are easy to deploy, easy to spin up, and there's a ton of benefits there we could talk about. The next thing that's a challenge with kind of traditional is you have each one of those servers they're running at 20-30% utilization. And so you're really not maximizing your total, you have a really high total cost of ownership. You got to patch each individual computer. We call it server sprawl, because you get all these different servers spread out throughout the whole plant. And now you've got to support 20, 10, 5 different servers all across the plant. And it's a full-time job making sure they're patched properly. They don't shut your plant down when they are patched, et cetera, versus going into one central type compute solution. So some of the modernization things that we'll talk about today is virtualization, thin clients. We'll talk about Thin Manager today. We'll show a demo, Rockwell demo running Thin Manager on our ZTC Edge here, and the power of providing content based on role, security, et cetera, location. A big thing that we talk about, if all that data that I spoke about is true, is the fault tolerant redundancy, providing applications and keeping them running. It's a very modern approach. And then life cycle is another big thing we'll talk about today. Is some standard computer platforms will need to be refreshed every 3 to 5 years, which means you have a pretty costly refresh rate, and a lot of times it's mandated that you do that. The big new space for us as a company and a lot of folks right now is this ruggedized modern edge computing. I want to be able to put a server in my Logix panel, right? I want to put it in a ruggedizer. I don't want to have to work with IT or I have a remote location that I already have panel space. I don't have an air conditioned room, or I just want to gather data on a line, at the line, like we talked about earlier with analytics and IIoT. And so that's kind of the birth child of the ZTC Edge. So we'll talk about all of those today throughout the presentation. I'll pause here. Any questions about what we talked about thus far? Are y'all seeing this kind of from a customer perspective? Are y'all seeing this kind of transition? Would y'all agree with some of the stuff we're talking about? Yes? Okay. Nodding heads is always good. And so obviously I asked most of you as you're like mid-bite in your sandwich, so I apologize for that. So kind of transitioning into kind of what our platforms are, we'll talk first about the ftServer. FT stands for fault tolerant. It is a fully redundant hardware solution. So if you notice, that's a 4U rack mount chassis with what looks like 2 servers, and we call them customer replaceable units, but they're actually mirror images of each other doing the exact same thing at the exact same time, all the time. The technology and kind of our secret sauce is that the lockstep technology that keep both of those running in lockstep. We like to say, or I like to say, Cole likes another example, I like to say they operate like your eyes work. So right now you're seeing the screen or me present. You have 2 eyes, 1 image, 1 brain. if you were to cover your left eye, your right eye didn't have to shut down and restart. It kept seeing the same image. That's exactly how our servers work.
Yeah, I use the example of jet plane, right? Airliner. So you got a single plane, you got two engines, at least two, right? All the engines are typically on, they're running, they're doing the same thing at the same moment in time. So if you lose one of those engines, you don't have to fumble around in the cockpit and try to, fire up the other engine. It's already there, it's already running. So you continue on with no total outage of service, right?
I don't love that example because normally, like today, he lives here in Houston. I'm flying back to Dallas tomorrow. I don't like about failed engines and all that kind of stuff. And I hit some really bad turbulence on the way in yesterday. We had the whole plane freaking out. When that happens, it's pretty crazy. But those are two good examples of how our solution works. When we say customer replaceable unit or crew, the halves are replaceable. You can see that. But while the applications are running, if there is a failure, say you're running USE and Historian, domain controller, typical architecture for a plant on this solution, and you lost the whole half of the bottom, the CPU failed, whatever happened. There's no failover time. So bullet number 4 and 5, no data loss. The application that was running here is still running here, but there's no switchover, there's no change, there's no downtime associated with that. The process keeps running. You wouldn't even know as a user that there was an issue unless we'll talk about alarming and notification of how we let you know what's going on here in a second. But it's that seamless. It's seamless. There's no bumpless seamless versus bumped in the oil and gas space. The key, and one of the things, obviously, we provide availability. Cole likes to talk about that. I like to talk about having worked in in the Rockwell side for 7 years in numerous different industries. Easy is what a lot of users are looking for on the OT side. If they're going to support a solution like this, operational simplicity is key. So if this was a failure, say that the hands are my hands, I'm pulling out that half of the server. If it failed today, we're going to notify you. Or the server can call home. We can notify you via a few other methods, SNMP, OPC, etc. locally. If you can't have the server call out in a secure manner. But the cool part is the server's smart enough to tell Stratus or yourself, and you can call Stratus, exactly what happened, exactly what's wrong. Next business day, you're going to have an entire replacement. As part of the support contract we offer, if this whole half failed, you're going to get a whole half from us, FedEx Air, next business day. Or that other thing that may fail is the hard drive. And so you're going to get the mirrored hard drive for the solution next business day. Anybody in this building can unscrew some thumb screws, pull the half of the server out. The units are hot swappable. You push the server in and you walk away. So from an operational simplicity perspective, you don't have to be an IT guru to keep and support a redundant server solution. I know that's why you guys chose Stratus, and if you want to talk a little bit about
Yeah, that's exactly right. And I want to add one more thing. The key component there is that not only do we get you the replacement parts quickly, but you're still up and running in the meantime because you had the redundant fault-tolerant hardware to begin with, right? So you're still up with no outage or data loss, and then we get you the part, you hot swap, plug and play, and then you're back up to fully redundant mode. And yeah, as Cody said, in my time in oil and gas, that's why we found and chose the ftServer really for availability, number one. So these were for control systems, like I say, in offshore facilities. Our applications had to stay up and running. So there was, if the applications would go down, they'd have to shut in the production and basically stop the facility. So we had to stay up and running, and that fault-tolerant hardware provided that for us. But also, these were offshore techs, automation techs or instrumentation electrical engineers offshore administering and servicing these systems. And they're brilliant guys, but they don't have the IT skill set to be able to monitor or service a complicated multi-node cluster solution. So the ability to just hot swap, plug and play replacement components to get back up into fully redundant mode was great for them from an OT operations perspective.
Two more things I'll touch. Okay, go ahead.
Well, specifically for your offshore applications, how did you handle the bandwidth issue or the phone home issue?
It's a great question. So I would say very typical for an offshore oil and gas installation is you won't have the internet connectivity, at least at the process control network side of things, right? So the bulk of our systems were actually not connected to the internet. So what we would do is use kind of local monitoring and alerting mechanisms And the end result is the same. If the server is connected to the internet and calls Stratus itself, great, that's the best way. It's the fastest, most efficient way, for sure. But if that's not a possibility, you use a local method like Cody mentioned, whether it's email, OPC, SNMP, the only difference being you would get the alert, as an offshore tech in that case, and you would place the call. From there, the service process is exactly the same.
Sure. Great question. We get that question a lot in this space. In a lot of spaces, security being paramount these days. Obviously it's a secure outbound thing. We've been doing it. We're one of the first to ever do the phone home 20 years ago, whenever we started doing it. So it's we can talk security if you want to, vet that solution out. But either way, there's an option available. Two of the things I want to talk about at ftServer. The first being licensing. So kind of going back to the third bullet, I don't remember if I touched on it, but as I mentioned, in a cluster solution, you have to have an application to fail over to. So you have to have a license for every server you have. Most people are like, oh, you got 2 servers here, you need 2 licenses. Because the system is running in lockstep, so tightly integrated, we have a really good total cost of ownership here, in that if you would only need a single license for the 2 servers, because it's one instance of that application running on both servers at the exact same time. And when you sit down to work on the server, it's like sitting down at your laptop. It looks like a single computer. You don't have to do it. The system takes care of the redundancy for you. The last thing I'll touch on is the second to last bullet is the life cycle of the system. The city of Lubbock is running a system right now, 4300, that they bought in 2006. So 13 years ago, they bought a server. They have failures every few years. They have a hard drive failure, or they had the worst thing that can happen. They had a whole crew fail, CPU fail somewhere along the way. And no surprise to us that doors always left open and dirt flies in there right into the server. But either way, they've always run. So they've been under support. We provided hard drive. We provided a crew to them to get them back up and running. They're refreshing it. We just got the PO last week, but 13 years. So my point there is we typically have our systems run 8 to 10 years life cycle, which is, if anybody's dealt with Dell, HP, et cetera, drastically different. Usually if it's not supported, they ask you to upgrade, and that happens usually 3 to 5 years, depending on the servers that we deal with. So those are the reasons that customers really choose us. Fully redundant application keeps running. Simple, easy to support, and then the life cycle of the system, which really all drive the very bottom bullet, which is the lowest total cost of ownership when we talk and compare kind of an apples to apples type solution. So I already talked about hot swappable, replaceable components. Last thing I'll touch on ftServer is that there's really 3 sizes, and we work with Rockwell and others to kind of size the system. Yeah, go ahead. To size the system based on your application. So we have sizing tools to help customers size their application, but kind of small, medium, and large, supporting 10, 20, and 30 plus virtual machines for your application. So we can scale with whatever, if you need a really small system or a really large system, we can scale to meet your needs. So as I mentioned earlier on, with all this data, contextualizing and putting data, putting an idea or capturing data and contextualizing it at a line, at the edge, kind of bred the ZTC. The ZTC stands for Zero Touch Computing. We took all the ideas and kind of features of ftServer, what we're known for, we try to package it into a ruggedized, scaled down solution. And that's really what the ZTC Edge is. It's a 2-node solution. So both of these are obviously servers, and they communicate across these 2 cables, these A-links. So we're providing software redundancy across these 2 solutions. So instead of in one chassis like we had for the ftServer, these are 2 separate nodes talking to each other across the A-links. We have 2 flavors here, and both of them use the operating system for us is Stratus Redundant Linux. It's included in the hardware, and so there's no extra license you have to buy from a virtualization perspective. We're able to run, get your VMs up and running in the Stratus Redundant Linux in a matter of 30 minutes. And here's an example. Actually, this is an example snapshot of what Cole has in his case over there. When we ship the units, we ship a front and a back page. that talks about in 6 steps how to get your system up and running. So obviously it's not as it's not hardware fault tolerance like we have in the other in the ftServer solution. It's split between 2 nodes that have to be communicating back and forth across the A-links. But the neat part here is you can do some different things with this solution, like split site, etc. But all that said, what we're doing here is we're running integrated virtualization and redundancy in a different manner, in a different form factor, in a different footprint, at a different cost.
At one point with regard to the installation. So, you know, the question that we asked is, you know, with a cluster system or a multi-node system that gives you this, you know, failover feature, basically, why does it have to be so hard, right? I mean, that's really the core of it. We talked to companies that are actually experts on these multi-node cluster systems. And they tell us that even, you know, if the experts are doing it and if everything goes perfectly, it'll still take them 3 to 4 days to stand up the system, get it all interconnected and talking, configured and tested and working properly, right? So the idea, as Cody said, was again, keep the continuous availability, but add the simplicity and repackage that in a ruggedized factor for small to medium-sized projects, right? And that's, you know, I think that what it says up there, less than 30 minutes is accurate. So I don't know if any of you were here when we were setting it up, but it's really just a matter of you know, unboxing the nodes, plugging in the color-coded cables and booting them up. And the installation process, you provide the IP addresses, 1 for each node, 1 for the system as a whole, and that's it. So the longest part of that 30 minutes is just you know, synchronization process between the 2 physical nodes. But it really is, you know, a simpler way to handle these high availability systems.
You don't have to load the virtualization layer. That's, you know, for me, I think that the easy part of it is it prompts you through 6 steps. Obviously, Cole has already set his IP addresses. He knows the config, and it takes us 10 minutes to set this up. But the beauty of, like, when you unbox it and you're walking through the steps, it's prompted, and we always will give it to an engineer and we'll say, hey, like, let's do some testing, let's set this up. And he just tries to start clicking through it. And I'm like, hey, he's like, what do I do next? Let's go back to the 6 steps, right? This is one of those things you actually should read the manual, because it's easier to read the 6 steps than it is to ask the question. But it is one of our favorite things to do. It's like, hey, what's back to the manual? But the solution really is focused on giving virtualization and configuring the virtualization in a, I mean, gosh, the story we like to tell is this. We had our general counsel and our CFO get in a room with an unboxed solution. So we gave them a box cutter and 2 ZTCs, and we said, go. And we timed them both to see how fast they could get it set up. And the general counsel, and obviously neither one of these people have a clue how to spell ZTC or servers. So that, you know, they're crunching numbers and reading legalese all the time. And they were able to do it. And I think he was able to do it in 31 minutes. She was like 32. A week later, we brought in the product manager's son. He's like 11 years old, and he was able to do it in 22 minutes. So it's almost Xbox, PlayStation-esque and how to set it up. It's very, very easy. But what it provides. So the neat thing about the solution is it's scalable. So for this solution here, we were asked to create a solution where I want a single node virtualization installed out of the box. I want to be able to easily plug in the second node. And now I have a high availability cluster just by plugging in the solution. This hardware right here that we're showing on the table was set up as an HA cluster, high availability cluster. The hardware on the screen is set up as FT, fault tolerant. So here in the HA example, I'll probably go to this slide and then come back. In the HA example, high availability example, if the application, say your Vue SE application was running on this node here, y'all's right. If this, for whatever reason, lost power, went down, the application would then restart over here in a matter of a minute or so. No interaction, no clicking, no running, no screaming, no asking where the license key is and getting someone to set the server back up or re-image a server, any of that kind of thing. It's just going to automatically restart. In the FT mode, fault tolerant mode, the application would actually be running on both nodes. And thus, if this one went down, your seamless kind of bumpless continue operating on the other node. And then the cool part is we talk about simplicity a lot with ftServer. Same thing here. You would come in, unplug network cables, unplug power, grab the new unit, put it up, set it down, plug in network cables, plug in power. It's going to boot, and it's going to get back in kind of that redundant mode in a matter of a few minutes. So again, for us, we really tried to scale not only the hardware solution, making it easy to scale up into a high availability solution, but we also scaled the architecture from an HA perspective to an FT perspective. So now we can support 3 to 4 VMs on this solution, 5 to 6 VMs on the FT mode of the 110i. This is the 100i hardware. The FT version is the 110i. And then if your application or needs expand past the 3 to 4 to 5 to 6 virtual machines, we can move into ftServer, which we talked about before. So now we really have a scalable architecture to provide easy, simple availability. Yes, sir.
You say you support the Linux OS?
Correct.
What distribution is that?
So on ZTC, CentOS, Ubuntu, Debians, Red Hats, so basically all of your most common Linux distributions. And same with ftServer. I would say this, ftServer, you have a number of different options about the operating system on the server itself, right? So you could run Windows Server, you can run VMware, or you can actually run Red Hat Enterprise Linux as the core operating system on the ftServer, right? On the ZTC products, as Cody mentioned, the core operating system on the physical box is called Stratus Redundant Linux, and it's actually based off of the CentOS distribution. But at a virtual machine level, as a guest operating system, you can run any of your Windows Server variants, desktop-style Windows operating systems, or most common Red Hat, Linux distributions.
Yeah, I skipped that slide. Great question. Kind of remind me to go back. What Cole just mentioned is exactly what it says on the left here. Is it supports Windows or Linux. You can load ISO files or OBF files. One of our most popular things to do is if you're using like a VMware, and you have a VM image, you can do a V2V, virtual to virtual conversion. Pretty simple process to convert to a format that you can run on a ZTC. And again, it doesn't cost you anything. It's a free conversion, and then our license is already bundled into the price of the solution. The key here is that very bottom bullet, right? Is there's no redundant clustering or config necessary. It's a 30-minute process, and you're ready to deploy, import your virtual machines. Another way we do that is physical to virtual. So we have a P2V converter as well to do a physical computer application, et cetera, into a virtual environment. But again, that's not anything special to us. That's just it's a utility that we provide. I'm going to pass it. I'll share the slides with the Reynolds company team, but for the sake of time, hopefully a lot of folks already know the benefits of virtualization. I have a little box there. It just really consolidation of compute resources, supporting legacy OSs and disaster recovery are usually the things you talk about. The last thing that we see, I talk about a lot with clients, is the very bottom bullet too. So today you're running a typical architecture, right? A SCADA application, USE, some kind of data collector, maybe a domain controller. Here in a few years, you're going to want to have an application for analytics. You're going to want to have an application for your own custom app, et cetera, et cetera. Being able to virtualize that environment and deploy, change, edit easily is one of the things that we've been talking to a lot of folks, definitely here in Houston, about. One of the big oil and gas companies here said they have like a 100-person team. All they're doing is working on creating crazy cool apps that do all kind of stuff, and having a place where they can run Linux or Windows in an environment that's easy to use is the feedback we got was game changing for us and for them.
On the edge server, how is the software licensing? How is it affected fault tolerant versus high availability when it comes to the Rockwell license?
There should be no difference in that regard.
So
it would still be a single set. That's right. That's right. The underlying technology between HA and FT is very similar. So there's obviously data being passed back and forth between the two nodes. You can just think of it as more data, not only your disk data, but actually your virtual CPU and memory state is passed across and synchronized for a fault-tolerant virtual machine. So the VM itself is exactly the same. The application is exactly the same. There's just more state data being shared to allow you to pick up with seamless bumpless transfer in a fault-tolerant mode.
How we're doing that is just the difference in hardware. So I mentioned these, we call these the A-links, which is just the two Ethernet ports that are constantly communicating between each. And this 100i solution, they're gigabit, and the 110i, this hardware here, they're 10 gig. And so we're able to, the amount of data and transfer that has to happen to keep them both up and running in that lockstep kind of esque mode. And the 110i needs a 10 gig. And so that's a big difference on how we're actually able to achieve that.
But in fact, you could take a virtual machine, say, from an HA 100i unit. You could export that VM and import that same VM over to a fault-tolerant 110i.
Great question. So I mentioned this gives us a little bit of flexibility on the architecture side too. One thing we like to talk about, and we've tested this to miles. We actually had a distributor in the Midwest just do this exact test with about 1,500 meters between the two, converting to fiber. But they do a split site. So obviously here, a lot of the things we see is kind of a co-located solution in a panel on, in the control logics cabinet, et cetera, on the wall, side by side. But if your network requirement and the latency requirements meet these published requirements, then you can split them, miles apart, feet apart, different panels. My coworker likes to talk about the 3 Fs: fire, flood, and forklifts, I think is what he calls them, that inevitably cause downtime. And this can help avoid that. So we've had some customers really be excited about that functionality. So I mentioned two models of ZTC. The one that's not listed here is what I would call the 100i-S, which we did a single node, but it's the same hardware. So the 100i, the 110i, really the main differences are two things. The one is able to run the FT mode, which is the 110i. It has more 6 hyper-threaded cores versus 4. On the top, you can run 3 to 4 virtual machines. Obviously, virtual machines are not all created equal, so it really comes down to kind of how you configure the VMs. On the bottom, the 110i can support 5 to 6 virtual machines. The other big difference here is the amount of NICs. You have all 6 of these available to you on here versus is it 2? Yeah, 2 on the 100i solution. And then lastly is the amount of storage. So 512 gigs of storage here versus 2 terabyte on the 110i. The RAM is equal on both solutions. So
there's one more thing to touch on here, Cody. I think with the ruggedization, right? So some of these specs, I think all of them actually are listed here, but just so you know, so obviously they're industrialized, ruggedized servers, right? So they're sealed chassis with no moving parts, no fans, and solid state drives, right? But they're pretty flexible as far as installation into a control system, right? So you can run them on a tabletop or a shelf and a rack, of course, tabletop like I'm doing here, but you don't have to. They come with wall mounts and probably most of these DIN rail mounts, right? So you can integrate them right into a control system cabinet with PLCs and other components. And the other thing to note is that the nodes themselves run off of DC power, nominal 24-volt DC. So again, you can connect them to your 24-volt buses in the cabinet with redundant power supplies, which is pretty typical in a lot of industries. And you can run them along with the rest of the instrumentation in the cabinet. You don't have to. You can run them off of AC with the AC to DC converters. But by nature, the nodes run off of DC directly. So between the ruggedization aspects and the ease of integration into your panels, and the fact that you can put them both in the same location or split site, we hope that offers a lot of flexibility for the customers as far as integration goes.
yeah, and temperature specs. You mentioned ruggedized, up to 140 F. From a temperature perspective, is if you're going to put it in a panel, is needed. So yeah, great points, Glenn. I mentioned this is the same as the ftServer on the support side. The system can call home. It's going to self-diagnose what's going on, monitor itself, call home, and then the automatic replacement of parts is the same. So no difference there. But some cool things that when we released the 110i, which just came out in mid-May, we released Stratus Redundant Linux 2.0, and we added some functionality and features that I'll touch on, and maybe Cole may add some context to. But one of the big things that we've been asked by clients is, I need to monitor my application in my VM, so kind of that full stack monitoring. And so you can do that. You can set alarm events, notifications based on CPU usage, memory, disk, etc. per VM, and it's all configurable in the web console. And Cole's going to show you that here in a minute when we kind of demo the 100i.
Yeah. This is a feature we're really excited about because, it's one thing to monitor your hardware, right? But this allows you to actually monitor the virtual machine itself and even the applications that are running on the virtual machine, right? So it's kind of a feature that's now included with the hardware that allows you to keep an eye on your whole computing stack, right? Which I think is pretty unique.
Yeah, absolutely, out of the box and easy to configure. I think that's, again, we'll say easy and simplicity and all those those similar type words to describe kind of both solutions. But again, from a point and click, an OT person can set these type of things up. Industrial monitoring. So we added some functionality around OPC UA integration into this and RESTful APIs to integrate more information out of the solution and monitoring of the solution. And then some additional security features that we added recently were the kind of host-based firewall, so you can whitelist and blacklist IPs in the box, which is a big deal if you have to deal with IT and security. Being able to do that type of activity on the solution is pretty exciting for us. We added some restricted USB port type functionality in the solution, and then trusted boot on the cyber security side. I don't know if you have a ton.
No, I was just going to mention one sort of funny thing to me, but again, back in the oil and gas days, hopefully you guys haven't experienced this, but for us, the biggest problem, if there was ever a virus issue or malware, it was the pesky USB drives. Because the guys would have MP3 music or something on their drive, and they would be in the control room, and they'd go ahead and plug it in there, and all of a sudden we'd have an issue. So it's kind of a simple feature, but it's probably the most important one, is to be able to restrict those USBs.
That's funny now, I guess, because there probably wasn't much.
No, back then it was a huge headache.
I thought I'd just share some successes. We talked about a lot of customers' names up front, but we can talk specifically if you have an industry, you have a question. But since we're in Houston, I thought I'd share a couple projects that we're working on, chasing after. And one kind of is I love this one because it really talks about the breadth of our product, right? The scalable compute. So if you're in a terminals situation, you can run 2 to 3 applications on a ZTC. If you're in a refining, you need to run a bigger historian, more full stack type automation solution. You can run a ftServer, and we have some installed, et cetera, et cetera. So the neat part is that it's a scalable platform and a scalable compute solution that we can offer depending on your applications and requirements. We can obviously scale up and down to support very, very large deployments on the ftServer. And a couple more projects. TransCanada is probably one of our favorites. They ended up purchasing Columbia Pipeline a few years back. They have 105 ftServers running on one of their pipelines that has, it started as a pilot. They had a high availability cluster solution. It went down. It cost them a bunch of pain and dollars. And so they piloted one compressor station with ftServer and liked it so much that they rolled it out across the 105 sites over the last 5 years. They're actually testing the 110i right now. And similar story, more scaled down a little bit on the Alliance Pipeline side. They recently purchased another 5 to 10 ftServers, and they're in the process of a proof of concept with the 110i just last week. So with that, I'm going to turn it over to Cole. He'll be able to kind of demo the ZTC, the console, how easy it is to use, show you guys some bin manager functionality running on the ZTC, and then we'll open it up to questions after that. So you want to share your screen?
Yeah, I'm going to share it on the Zoom, and then I guess what we need here. Okay, that was easy. Okay, so we only have a few minutes left, so I will rush a little bit, but I'll try to show you guys at least so you get a little bit of a feel for the administration and monitoring and access of this system, right? So the first thing to talk about is, how do you access it, right? So we briefly mentioned IP addressing. Each node has its own IP address on the management network, but there's a single system IP that can float between the two nodes. If there's ever a failure, the other node will take over that address. So all you need to do is open a browser and point to that system IP of the ZTC system, the static IP there, and you're into the administration console, right? So everything you do to the system is done from here. We call it the ZTC console, and like I say, it's just a web-based GUI that's pretty similar to a lot of the other tools you guys have probably already used. So I'll try to show you three things. We'll talk about monitoring, and maybe talk about administration, and then we'll talk about accessing virtual machines. So monitoring, there are a number of ways that you can do it. Accessing the console and using the dashboard is probably the easiest. So the dashboard gives you kind of a pictorial representation of the system at a glance. Any sort of issues that would happen would be highlighted here with yellow warnings or red exclamation points, right? But then there are a number of additional monitoring methods as well. So the first and foremost would be the call home feature, where the system would automatically report any issue to Stratus, right? So if that feature is enabled, that'll happen automatically behind the scenes, right? But locally, there are some additional options as well. So email alerts, right? So that it's a really easy one, but really useful. You can configure a mail server. So there's not a mail server on the box, but if there's a mail server on the network, you just point to it using your authentication there. You can see that I actually have mine configured to run off of my Gmail account, right? And then in the e-alerts tab, you would set a list of recipients, and that's it. So whenever an issue would occur, the same stuff that would get sent back to Stratus would also be sent via email into the list of recipients that you define. Other ways, if you have some more IT-based tools, so we talked about a little bit about SNMP. So Stratus has what we call a management information base. It's a MIB file. If you guys happen to use SNMP at all, it's basically a data dictionary for all the data points that we offer. So you would download the MIB from our site and import it into your tool, and you can either request data from our system, or our system can push data to you if an event occurs. And maybe the most popular method for monitoring, especially in industrial automation, OPC UA, right? So a lot of the time, your operators are already seeing data on their HMI. They're used to their alarming methods on their control panel screens. So the OPC interface would allow you to read data from our system via your SCADA, and then alarm on it and show that on the screen just like any other data from the production system. So we try, like I say, to have a number of methods that if any issue happens from a hardware level, that you'll know about it right away. But then we talked about software and virtual machine monitoring as well, right? So I will quickly show you what that looks like. At the virtual machine level, and I'll explain a little bit more about these tabs in a second, but there is a monitoring tab for each virtual machine. And it's probably a little small on that screen, but and I won't go through the details because of time, but you can basically configure alarm thresholds based on resource utilization of the virtual machine, or based on status of the applications that are running on that virtual machine. And if any of those alarm conditions are triggered, you can configure it to either notify Stratus via the call home, or notify you via the emails and the SNMP traps that we just discussed, right? So when we talk about administration, anything you want to do as far as your virtual infrastructure, you would again do from this web-based console. And most of it is really easy, kind of point and click and wizard-based. So for instance, you can create a virtual machine from scratch. We just have the create button here on the virtual machine tab. And this would allow you to build a clean, fresh virtual machine that would boot off of a virtual installation media. This is the virtual equivalent of, if you guys have ever put the Windows CD into your computer and reloaded it from scratch at home. And again, that can be a Windows or a Linux-based virtual machines. Maybe more useful and more efficient is if you have backups of machines that you previously configured. You use the import restore wizard there. A virtual machine that's exported from our box. If you guys are familiar with these virtual machine formats, it's an OVF file and then a virtual disk file. So you would just browse for that OVF either from your management PC or from a USB drive or over the network, and you can easily just import that into the ZTC. Cody mentioned a couple of the other methods for administering and creating virtual machines, and those are conversion of existing physical machines or existing virtual machines. And those, as he said, you do those, we provide a utility. You boot the physical machine or the virtual machine, and then over the network, it converts to the ZTC and transfers all the data on the fly. The other thing I'll mention from an administration perspective is upgrades. When we release a new version of the operating system, we have an upgrade kits tab here, and that's how we release it in the form of an upgrade kit. You would download the kit onto your management PC, and then you would simply add the kit, qualify the kit to make sure it's appropriate for the software that you're currently running, and then you hit the upgrade button. And the neat thing, since we have 2 nodes, we can apply updates to the entire operating system online with no downtime, right? Because basically the way we do that is by moving virtual machines live. With 2 nodes, each being able to run the full workload, we can move all of the virtual machines to node 1 while we update the software on node 0. Then we flip-flop that process to update the software on node 1. And at the end of the day, your whole system is up with the new software without any interruption or maintenance window required. So that for me is very important, because a lot of times there may not be a plant shutdown or a maintenance window, but there might be a critical patch that you need to get installed. The last thing I'll briefly discuss is accessing virtual machines. So anyone who's familiar with virtualization will understand the concept of a headless system. But keep in mind, this is a headless system, as we say. In other words, during normal operation, you won't have a keyboard, mouse, and monitor physically connected to either of the nodes. You could do so, but you'd only see the output from the underlying Linux operating system on the node itself, right? So to actually access your virtual machines and applications, you need to use a number of remote methods, right? The easiest one is, the quickest one is right from this web-based management console. You go to the virtual machines and we have a console button. And when you click it, it would just open a console in a browser tab. So there you see the actual display of a Rockwell demo virtual machine that's running on these ETCs, right? Other methods are remote desktoping, very commonly used, but we love to talk about thin clients, right? In this modern plant architecture, thin clients are going to be huge. Instead of having all of these custom configured computers with operating systems and applications loaded all over the plant or the facility, you just have these simple 0 client or thin client devices, easily replaceable, easy to connect to the network that pull all of their content from the virtual machines running on the ZTC, right? So I have a quick example of that. This is the Thin Manager, the Windows client version of Thin Manager that's running on my laptop. So I am connected, and again, pulling this content from virtual machines that are running on the ZTC, right? So I don't know if you guys have used Thin Manager before. Cody likes to tease me and say, maybe I should work for Rockwell.
So if he ever gets fired from Stratus or he just decides to leave, he'll work at Rockwell.
I like it a lot, is the point, and it's extremely powerful. Like I say, my software development years, to be able to do something like this, and create a quad panel display, just pointing and clicking. I mean, blew my mind how easy it was to do, and the ability to customize and deliver content based on user, based on role, based on location. All of that is really neat as well. And then this, probably commonplace for you guys nowadays, but for me, it still blows my mind. Just the fact that with a couple of clicks, I can have that exact HMI perfectly scaled and delivered to my mobile device. It's a really powerful thing. This would have been like a year-long development process for us in my former role. So,
by the way, he's talking about free software. If you buy a Panel V Plus, that viewpoint is free software that comes with it. So no one uses it, or not enough people utilize it.
So I hope that gives you at least a decent overview of what the console looks like and how you would use the machine. Let us know. Of course, we'd be happy to dive into more detail with you. We can do live demos. We can certainly set up additional testing if you need to know more.
Yeah, one thing I'll add to Cole, if you notice on the right side here, it shows like little depictions of the 2 ZTCs. So you can see that the running VM, the one that he just showed using Thin Manager, running on the right is on that node. So in this hardware, just to kind of pull all of it together, and this hardware, whatever that was running on, whatever node that was running on, if that node died, the VM would shut down. We would lose, if he was showing his screen still, he would lose connectivity, and then the VM would move over within a minute or so. It would restart. But Cole wouldn't have to click anything. Just like you as an operator would have to click anything. It would automatically do that. You would get notified. You would replace the unit, plug in 3, 4 cables, 5 cables at most, and walk away. And then the application was one of my favorite things, and I think it's black magic or wizardry or something, but somehow the secret sauce of the OS can, as he mentioned earlier, live migrate your application back over. So there's no shutting down the application again to get it back on this node, say this was the one that was supposed to be on. The VM will live migrate, and you can see it spinning here. It'll say moving, and then it'll move back to the node it's supposed to be on, because typically it'll load balance, but you can also deploy VMs to sit on certain nodes. So that part to me is really cool. Obviously in the FT version of the 110 I hardware, the VM would be running on both nodes. So if there was a failure, it would just keep running. No blip to the SCADA. But the replacement and keeping the application and plant running without a ton of interaction is really what the name of the game here is for really both solutions, but even more specifically on the ZTC edge. So with that, I'll open it to questions. That's the content we had today. We'll provide the content and presentation to the Reynolds folks to be able to publish online. But any specific questions about what we went over? No. Fantastic. Well, thank you all for being here. If you have questions, you want to see more, stop by. We'll be down here with the system set up for probably 30 more minutes or so. Let us know if you have other questions after the fact, or you want to review your specific architecture at your plant. We love to have those conversations as well.
Yeah, and the last thing I'll mention is I briefly mentioned it earlier. If this is of interest to you, if you want to learn more, just get in touch with Cody or myself anytime. We're here to help. Keep in mind, we don't expect you to, just see some slides and a 30-second demo and think that, okay, it must work like it says it does. There's no substitute for testing is what I'm getting at, right? So we can come in, we can meet with you, we can show you a demo, we can even get you a testing or a proof of concept box, a set of ZTC nodes for yourself so that you can install your own applications, test in your lab, and actually see it working in front of you there. So
same goes for ftServer. We just actually had the other office here at Houston. We had the team and a client in, and we pulled power out of the back of the half of the server. And they pulled the whole half of the server out. They took the lid off of it and looked inside, and we put it all back together, and he shoved it back in, and within a minute or so, the application was copied across and back up in lockstep mode. So that's also, if we get to that step and you want to see the hardware running, we always like to say proof is in the pudding, if you will. Like nothing, no better way to see it than live in action. So seeing is believing.
that's right.
Anyway, thank you very much. Appreciate it, guys.